In this video, we're going to be doing a break-even analysis. Now, the total cost C of producing X units of a product typically has two components or parts. Now, the initial cost and the cost per unit. Now, when enough units have been sold so that the total revenue R equals the total cost C, the sales are said to have reached the break-even point. So you can find that the break-even point corresponds to the point of intersection of the cost and the revenue curves. So let's take a look at how this would work through an example. So a small business invests $10,000 in equipment to produce a new soft drink. So each bottle of the soft drink costs 65 cents to produce, and it's sold for $1.20. So how many bottles must be sold before the business breaks even? Well, our cost for producing X bottles is going to be the total cost. So our cost per bottle times the number of bottles plus the initial cost. And our revenue is obtained by selling X number of bottles. So our revenue is the price per bottle times the number of bottles. So if we come back up into our problem here, we can see what is our cost per bottle? Well, it costs 65 cents per bottle to make. So our cost is going to equal 0.65. We don't know the number of bottles yet, but we do know that it cost us $10,000 in initial costs. Our revenue is what we're trying to find as well. So it says that it's going to be sold for $1.20 for each bottle. And again, we don't know how many bottles we're selling yet. And so here we have two equations that we're looking at. C equals 0.65x plus 10,000, and R equals 1.20x. Now, because the break-even point occurs when the two equations intersect, so where R equals C, right? So we're looking for where does R equal, where does C equal R? Well, that means that we can substitute in, we can plug stuff in. So what we're going to do is we are going to take our R value right here, and we're going to plug it into the C's spot. So we're going to take 1.20x and then set that equal to our 0.65 x plus 10,000. So it's kind of like solving a system of equations, which is really all we're doing right now. So from here, we might need to think of, if it's giving you a difficult time, remember that because C equals R, that technically we're able to say that this is also equal to C, right? So this piece right here, we know, because this is the break-even point. And that's why we were able to plug that in. All right, so from here, now we're just gonna solve this. So we're gonna subtract 0.65x from both sides. And that's gonna give us 0.55x equals our 10,000. And then from there, we'll divide both sides by 0.55 to get our number of bottles. And so we're going to find that our number of bottles is going to equal, probably going to round up on this one to a whole bottle, so 18,182 bottles. 18,182 bottles. And so that should be our solution. And we can double check this by plugging those equations into our graphing calculator. So if I plug both of my equations in and I hit graph, if I'm on a standard graph, I'm not really going to be able to see what I need. So I need to change the window. So let's say that we're selling between 0 and 25,000 bottles. That's too many zeros. There we go. And let's count by, it might be easier to count by 5,000. And let's say we have 0. And let's go for, as far as revenue goes, let's say 35,000. And let's count this also by 5,000. So now we'll hit graph. And now we can see where our two equations intersect, right? So this point right here, this is our break-even point right there. So at this point, we have a loss in the business. And here, everything is going to be profit. But this is where we get 0, right? We break even finally. So we can calculate that using the calculate feature. So second, calculate. We're going to choose option number 5, our intersect option. And we have our first equation and our second equation. And we hit graph, and we see that we have about 18,181.8 or 18,182 bottles, just as we found with using substitution. And so this is how you can find a break-even point with your equations.